Welcome to the sixth part of thermodynamics. In this part, you will learn to apply first law of thermodynamics on various processes, and we will calculate the work done in the isothermal process. Adiabatic process, in which no heat enters or leaves a system. That means delta Q will be 0. And prevention of heat flow can be accomplished by surrounding system with a thick layer of heat insulating material like cork, etc. Flow of heat requires finite time, so if a process is performed very quickly, then process will be practically adiabatic. From first law of thermodynamics, delta U is equals to minus delta W for the adiabatic process as delta Q is 0. In adiabatic process, change in internal energy of a system will be magnitudely equal to work done by the system. And if work is done on the system, then delta W is negative, and that means delta U will be equals to delta W. For adiabatic process of ideal gas, the relation between pressure and volume is given by PV raised to power gamma is constant, where gamma is equals to Cp by Cv. So for an ideal gas, if it undergoes a change in its state adiabatically from P1V1 to P2V2, then we will have P1V1 raised to power gamma equals to P2V2 raised to power gamma. And the PV diagram for the adiabatic is shown. You can see the PV diagram of isothermal and adiabatic process is similar. But there is a change in the slope. And that is because of in isothermal, we use the equation PV equals to constant, whereas in adiabatic, PV raised to power gamma is there. In an isochoric process, volume of system remain unchanged. That means the delta V will be 0 and hence delta W will be 0. Therefore, from first law of thermodynamics, delta U will be equals to delta Q, means all the heat given to the system has been used to increase the internal energy of the system. And for an isochoric process, P by T must be constant. That means pressure increases as the temperature increases. And the PV diagram for isochoric process is shown. Isobaric process, in which constant pressure is there. So, for work done, W will be equals to P delta V. That means you can replace it in terms of temperature equals to nR into delta T. And by first law of thermodynamics, you have delta Q is equals to delta U plus delta W. That means V by T is constant, means volume increases as the temperature increases. And the PV diagram for isobaric process is shown in the adjacent figure. Cyclic process, in which the system returns to its initial state, means delta U will be 0 and delta Q will be equals to delta W. And for a cyclic process, PV diagram is shown. in which the steps are isothermal adiabatic, then isothermal compression and adiabatic compression. To summarize various processes in thermodynamics, you can see in isothermal process PV is constant, in isobar P by T is constant, isochoric P by T constant, and adiabatic PV raised to power gamma is constant. And by putting this relation in first law of thermodynamics relation, you will get the relation between delta Q, delta W and delta U, as we have done already. Let's calculate work done in isothermal process. You know, an isothermal process is one in which temperature remains constant. Consider pressure and volume of the gas changes from P1 V1 to P2 V2, and the graph represents expansion for an isothermal process. At any intermediate stage with pressure P, volume changes from V to V plus delta V, where delta V is very small. Then from first law, delta W, you know it is P delta V. And to find out the total work done, we have to integrate it within the limits V1 to V2. Also, you know that PV is equals to nRT. So by putting the value of P from this equation, nRT by V, in the work equation, you will get integration within the limits V1 to V2, nRT divided by V into dV. On integration, you will get it as nRT ln V2 by V1, where n is the number of moles in the sample of gas given. And to change ln into Le, you know that we have to multiply with 2.303. So the work done will be equals to 2.303 nRT log V2 by V1. And in terms of pressure, it will be P1 by P2. So you can conclude from this work done equation that if V2 is greater than V1, W will be greater than 0, means positive, and vice versa. That is, in an isothermal expansion, the gas absorbs heat and does work, while in an isothermal compression, work is done on the gas by the environment and heat is released.